So you've just learned how to integrate exponentials. What do we do with that? Well, the applications of integrating are always finding the area underneath curves. That's why we integrate. So there's three skills that you've learned in previous topics. You've learned to find the area between a curve and the x-axis. And we do that between some bounds A and B by integrating y, or f of x. And we use our square brackets to find the definite integral. And if we get a negative answer because an area might be below the x-axis, we know that we can convert that to a positive area because areas need to be positive. And if we've got areas that dip above and below the x-axis, we need to break it up into sections so that we're finding the positive areas and the negative areas and converting them into positive answers and then adding it all together. We also have learned how to find the area between a curve and the y-axis by changing the form of the equation so that it's x equals something and then integrating that with respect to y. But we won't be doing that with exponential functions. And the reason we won't be is because when we rewrite an exponential function in terms of x, we end up with a log. And in this course, we don't integrate logs. There's no simple, easy way to do it, and it's not part of this course. So we won't get questions like that for this topic. But we will be expected to find the area between two curves. Now, to do this, if we have one curve that's higher up or has higher y values than the other, then we put it first and we subtract the high one. We do the high one minus the low one, and we can put it all together as one function and integrate it in one go with our square brackets. So let's have a look at an example of each of these. In this example, we need to use shifting to sketch a curve, and then we need to find the area between the curve, the x-axis and the y-axis. Now this question has led us in really nicely by asking us to sketch something, but a really good rule of thumb is that when we're tackling these sorts of questions about area, performing a quick sketch is actually a good idea anyway. So that's something that you can do. It's a red hot tip. Draw a simple little sketch, even if it's just something like this, that gives you an idea of what you're doing. All right, now I know that y equals e to the x does look something like this, and I can draw it super fast. So what does it look like when I've subtracted e as a tacked on thought sort of at the end of the function? Well, it means that I've shifted it down e units. So instead of having an asymptote here at 0, it's going to have an asymptote down lower at minus e, which I know is around about minus 2.7 or so. So let's perform our sketch down here. We've got minus e here for our asymptote. And now it's just a matter of moving everything else down e units. So the other known points that I like to draw on this normal sketch, I know that we go through a y-intercept of 1. So if I've moved it down e units, I'm going to have 1 minus e. And that's going to sit around about here. Now, knowing that e is around about 2.7 helps me get the scale roughly right. I need to basically make that point exactly 1 unit above, because I know that from the asymptote up to that intercept is 1 unit. So I'm going to label this as 1 minus e. Again, that helps me use exact values. I don't even need my calculator to figure out what it is, but I know it's roughly minus 1.7, and that helps me get the scale roughly right. Now I can go ahead and just sketch in my rough shape and label it. This is a point that I need because to find the area that sits between this curve and in here, I'm going to need to know what my upper and lower bounds are. Obviously my lower bound is going to be 0, but my upper bound is going to be this. So how do I find an x-intercept? I let y equal 0. Okay, so let's rewrite this with the y being 0. We have e to the x minus e. And now we need to get the x by itself. So let's add e to both sides, and we'll have e to the power of x equals e. I'm going to write it down that way. And now I can rewrite this as a log and say e to the power of x is equal to e. And I can see that this is 1. I could also perhaps have said, hey, this is e to the power of 1, and that's e to the power of 1. Whichever way you go here, whether you rewrite it as a log or you spot the answer there, either way, x equals 1. So I have that here. Now another way I might have found that quickly and easily might have been by taking the known points I have off this graph and putting them here. When we're graphing this one, isn't it normal to include one other point just for scale? And a point that I often like to include is x equals 1, because it's nice and easy. So when x equals 1, normally y equals E. So that's a point, 1e, that I normally put on my graph of y equals e to the power of x. So if this is height e and I've now moved the whole graph down e units, it makes sense that that known point when x equals 1 is now down on the x-axis, which is right here. So there's a chance that you can always take what you already kind of know and figure it out without having to use any of that working there. Now my sketch is done, so I'm ready to find the area now. So I'll write area equals, now I need the definite integral between 0 and 1, and I'm finding an area here that's sitting below the x-axis. So when I find my integral, it's going to be negative. Now you've got two choices. You can let the answer drop out as a negative number and then say, all right, the area is whatever. Or if you've written confidently here, area equals something, you can put your negative at the front, knowing that when you get a negative answer with the rest, it will multiply by the negative and make it positive. Up to you, it's fine to do it either way, as long as you know what you're doing. Okay, now we need to just put our function in and write that we are going to integrate that. Now I've got my negative out the front of my big brackets. Integrating e to the x just gives me e to the x. And integrating minus e gives me minus ex. Now, as always, double check that this differentiates back to that. Differentiating e to the x gives me e to the x, and differentiating minus ex gives me minus e, so that looks good. So now I need to sub in 1 for x, and then subtract subbing in 0. So I've got I've got a negative out the front, and then I've got e to the power of 1 minus e, and then I have minus, I need some more brackets now, e to the power of 0 minus 0, and then close brackets. There's quite a lot of brackets there. Notice how my negative is sitting out the front of giant brackets for the whole thing, whereas here I always use brackets for the second part of my definite integral. So I've got e minus e, that's nothing, and here e to the power of 0 is just 1, so I'm going to have minus 1 with a negative out there, so my area is going to be 1 unit squared. An alternate setting out would have been to say, let's just start with our integral, and let's say what that equals without the negative out here. And what we would have got at the bottom of all of that would have been minus 1. We would have put units squared here because at no point have we mentioned area, we're just finding the value of an integral and finding that it's minus 1. At that point then you could say, therefore, area equals 1 unit squared, and now you're stating clearly what the area is at the bottom. So you can set it out however you like. In this example, we need to find the area between two curves, and once again, the best tip to start with is a sketch. Now it's really important that you know which curve sits up above the other one. So a quick inspection of these, we've got 2 and a bit, or 2.7 raised to the power of x. Now remember that exponentials are far more powerful and they generate much bigger numbers than just squaring x. So even if this was 2 to the power of x and this is x to the power of 2, anything to the power of x is going to be much bigger than x to the power of 2. So I know that the e to the power of x curve sits up higher. It also starts here at the 1 and sits like that, whereas my parabola goes through the origin here and comes up, and it's going to be sitting below. Not a great picture, but that's good enough to show what I'm doing. Now I need to find the area between the curves from values of x between 0 and 2. So I'm working with my lower bound of 0 and my upper bound of 2. In other words, I'm finding this area here. So if I just integrated the top curve, I'd get the whole area between it and the x-axis. That's too much, okay, all the way down there. And if I just integrated the bottom one, I'd get the area down here, which is still white. I don't actually want that. So you can see that to find the area between the two, I do the upper one, which is that whole space there, minus the lower one, which is this bit that I don't want, and that gives me the area between, which is the part I did want. And I've now made quite a mess of my picture, but we get the idea. Okay, so to do it, I need to, again, I can set it out 2 ways. I can say area equals, and then just come up with an answer. or I can find an integral and then at the bottom say therefore area equals. So we saw that that second strategy can be better perhaps if you know that the answer you get is going to be negative, stops you being confused, also stops you needing it to put a negative out the front. I can tell here though that I'm not going to get a negative answer because everything's above the x-axis. So I'm just going to confidently go in with my area equals and then calculate the integral, and that should give me the correct area. So I need e to the x on the top minus x squared dx. I can put them both together like that and integrate them one at a time, and my bounds are 0 to 2. Now I need my square brackets and I need to integrate each term one at a time. Be careful with this one that you don't actually accidentally differentiate it. As always, I double check that this is right by differentiating these and checking that they actually get back to those. And now I can sub in 2 in both places and then subtract the subbing in of 0. So I've got e to the power of 2 minus, well 2 cubed is 8, so that's 8 thirds, minus, now I need brackets, subbing in 0, I've got e to the power of 0, minus 0 on 3. So 0 on 3 is nothing, I can get rid of that part. And now I've got e squared minus 8 thirds minus 1. Now I know that 8 thirds is 2 and 2 thirds, so I've actually got e squared minus 3 and 2 thirds, and that's how many units squared I have, which you can just write with or without the brackets there. I think the brackets is nice to say that's our number, and you can write u squared to save time there as well if you like.